afternoon. My name is Eloy Ortiz. And this is?
I'm Lyon.
And we work for a nonprofit called CTR. And we're here today to talk to you about the self-recruitment, creating ICT pathways from high school to college and work for underrepresented groups. This is a project that is being funded by the National Science Foundation. It's in its beginning stages, and we just want to talk to you today about the project. So today what we'd like to do is, again, introduce you to the project. Lynn will be talking about the first two components of the project, self-recruitment and ICT pathways. And then for the second part of the session, we'd like to have a group discussion to get your input on some of the concepts and ideas that we're looking at in this project. And what we'd also like to do is we will be taking notes, and we'd like to send out copies of the notes by the end of the week about the discussion. So, here we are. So, both Lynn and I, again, work for ETR. We are a nonprofit based in Scotts Valley, California. It's near Santa Cruz, if you're not familiar. We also have offices in Oakland. ETR stands for Education, Training, and Research. We're mostly known for our public health work, but we've also, over the last 10 years, we worked in Watsonville and parts of Santa Cruz County to increase the number of girls and Latinos interested in pursuing computing classes and careers. Most of our funding for this work comes from the National Science Foundation, and is part of their efforts to increase diversity in STEM fields. The work that we do is done in partnership with schools, after-school programs, faculty, and students from UC Santa Cruz and Cabrillo College from time to time. Most of our work over the last 10 years has started with middle school students, where we've administered enrichment courses, a lot of after-school enrichment courses with middle schoolers, bringing them to after-school programs where they're taught to create video games, while also at the same time showing them computer science concepts and programming skills. So this is something that's been going for 10 years, and it's actually ongoing. We're about to start another program, one of these projects this month, actually. And so, sorry, Jacqueline. Again, 10 years ago, we started with middle school students, and as the students have started to age out to high school and community college, our attention really turned to the community colleges, because, again, working with students in Watsonville and some parts of Santa Cruz and other parts of Santa Cruz County, there just weren't a lot of options for them as far as pursuing computer science in colleges. Next, please. So again, this project is called Beyond Self-Recruitment. It's an exploratory 2-year project funded by the National Science Foundation ATE grant. There's 2 components. The first is called self-recruitment, which Lynn will go in more depth about. But it's basically a term we're using to describe the process of adding computing content to classes in which target underrepresented students are already enrolled right now. The second component is creating pathways from high school ROP programs to colleges. And these strategies build upon work that's already being done by the ROP programs and by some of the colleges. And it's also building on work that's already being done by MPICS itself. So, and then the reason that we're focusing on ROP classes is because those classes are already focused on preparing students with career technical skills. But as we've seen from talking to ROP administrators and ROP teachers, that they don't always align to college and workforce needs. Next. Okay. Just want to go through our principal investigators. We have faculty from Cabrillo College, Belinda Brady. She wasn't able to make it today to our session, but she actually is here. Tom Riddle, who's right over here. Jill Denner, who's really the Jill Denner from ETR. She's really the driving force for the youth and IT work that we've done at ETR over the last 10 years. And then, next, please. Our partners, of course, National Science Foundation, Cabrillo College, Monterey Peninsula College, and Hartnell. These are 3 colleges that are near rural agricultural regions with high Latino populations, where there's just not a lot of options, and there's not a lot of, and these are actually colleges that are also close to Silicon Valley, but they're having a hard time connecting with Silicon Valley, with a lot of the companies in Silicon Valley. So, much like MPICT, ETR sees itself for this project as an intermediary agency, and we're working to build strong and sustainable partnerships between high schools, community colleges, faculty, and representatives from the high-tech industry. So the grant proposal was actually driven by the needs of the partners. So for community colleges, there was a need to increase the diversity of students who are taking computer science courses. For ROP, for those of you who may know, ROP's funding is being slashed, so this may be creating alignment between ROP and the community colleges might be a way to create some funding sources for ROP classes. For high school teachers, we spent the last few months talking to high school teachers. I think it's clear to me, and I think Lyon, that there's a need for infusing more alignment with and connections between what high school teachers are teaching and what's needed out in the workforce. And then for high-tech employers, of course, diversifying the pool of employees and for the high-tech sector. Next, please. And then just a few of our advisors, which we're still in the process of recruiting. Olivia Hereford, Mark Guzdiel, who is a professor in College of Computing at Georgia Tech. He's also a leader in non-traditional entry into programming through media computation, which Lyon will talk about in a few minutes. Next. And then, so again, just wanted to give an introduction. Lyon's going to talk to you about the 2 program components, and then we'll have a good discussion.
All right, thanks, Eloy. Again, my name is Lyon. I'm brand new to ETR. I just started October 1st. But I was very excited when I came aboard. I just finished my Ph.D. in Learning Sciences, and one of the things that I found in talking with students as part of my dissertation is that a big reason girls don't go into computer science is because they just don't know what it is. So I was very excited about this project because this whole idea of what we're calling stealth recruitment is to go into classes where the girls already are, where they're already enrolled, and put in some content that introduces them to computer science or these kind of computing, computational thinking concepts. So I was very excited about that because it seems like it's a way to get them interested in it without them actually having to make the effort to go enroll, to become interested in all that. So what we've done is we've looked for classes where there are already girls enrolled. And these classes tend to be, as we found, such things as graphic design, digital photography, film, and web design. Okay. Okay, yes, next one. Okay. So once we've identified these classes, then now our challenge is to figure out what content we can put in these classes. So that's what we're working now by talking to the high school teachers. What is it we can put in these classes that will give them some good ideas about computer science, programming, and other ideas, and how those can fit into what they're already doing. So we need to find content that meets our various criteria, which are things like it's interesting to students, because you really don't want to go in there, put in some computer science, have them hate it, and be turned off, right? So it has to be something that's interesting and enticing to students. It also needs to introduce some computing concepts. So in some of the cases we're looking at for example, is programming. How can we do some kind of little programming exercises that will get them to know what the idea is behind it? We also want to have content that gives skills that then would be useful to them at community college, because the idea is to create this pathway so they have to be able to move from these high school classes into community college classes. So we're also looking at what skills they have and how will that lead them into community college. And then finally, one thing that we're finding may be a challenge is what content can we put in that high school teachers are comfortable teaching. So it has to be something that they're comfortable with as well. So one of our advisors, Fidel Mejia, is both a technology coordinator and he teaches some of these ROP classes. So we brainstormed with him some different ideas about what kind of content we could put into these classes. The things we came up with were things like Photoshop scripting. So in these classes, they're already using Photoshop. So maybe they could start writing some scripts within Photoshop itself that would give them some of these programming concepts. Or he suggested creating apps. He says students really enjoy doing that. They can pick apps that are interesting to them, so they're motivated to do it. Another idea was web page creation. He said you could make dynamic web pages, you could program in HTML, you could link to a database, you could do things like that. So those were some ideas that we brainstormed with him. The idea that we had when we actually wrote the grant for this project is what's called media computation. And I taught some of this. I was on the faculty at University of Washington, Tacoma. I was teaching the minor classes for students that were interested in computing but didn't want to do the major. And I was really excited about media computation because to me I think of it as a similar idea to when you're learning a language. When I learned Spanish, at that time anyway, the classes were all grammar. You started with the grammar, and it was so boring. I just wanted to talk to people. I didn't care about the grammar constructs. And for me, I thought, wow, with this media computation, you're doing exercises that are interesting to students, things they want to be able to do. And oh yeah, programming's a tool to how you do that. So I was excited about that, and I thought it was a very interesting way to introduce programming to students. And the idea behind media computation, you can go to the next, is that they take digital images or digital music and they manipulate it using programming. So they're interested in it because they're having fun manipulating digital pictures. But the tool that they're using to do that is Python programming. And so as they get more and more, doing more and more advanced things, they're learning more and more programming. So again, it's a way that the students are excited. Ooh, look, look what I can do with my picture. And oh yeah, we're learning programming. So that's just a tool or a way to do that. So I'd like to look at some examples now of the type of projects students do. If I could have the next slide. So here's one, for example, where you can see they combine two images. And in media computation, he starts with, he does things in a little bit different order. So for example, he starts with looping, because in these digital pictures, he talks about red, green, blue values for each pixel, and so you get the idea you want to loop through each pixel and change or copy or do something with each pixel. So the order is a little bit different than it might be in your traditional introductory programming class. So you can see here a student used this green screen technique where they combine these two pictures. She put herself in a background picture of her choice using media computation. Next slide. Oh, that one. And here's another example. So here you can see the student is copying the pictures, so they have 6 of these images, also changing the colors. So they're examining each pixel and changing colors values based on some criteria. And also you can see they're doing this sort of mirroring effect, where they're taking the picture and they're mirroring it half. So again, just by copying pixels in that case. But these are some of the types of projects that they do in media computation. Next slide. And just a simple example here, he shows, Mark Besdale shows a picture of his wife, this is Barbara Erickson, and he's just added a little text to the picture where it says copyright information. Next slide. And you can see here the code, here's some just simple code, where he's added that line to the image. So you can see he's introducing these different programming concepts with an outcome that students are interested in or an output. The second component then is these pathways. So once we've gotten these students interested, then what? Then what happens? And so that's a piece that we're working on now. So the first thing is we believe that we need to be explicit in the high school class. They need to say, oh, look, by the way, this is programming. You know, if you're having fun here, then maybe you'll enjoy programming. So a piece of it is we have to tell them that's what we're doing. Then we need to, again, be explicit about the pathways they have then. So again, we're trying to figure out then how that will feed into community college classes, where the skills will be useful, and that kind of thing. And finally, we also want to bring in industry. So we also want to tell students what types of jobs then are available and how these skills can be useful in the workplace. So it's putting all those pieces together so that students have a clearer idea of the path through all these various steps and so on. And so far, the work we've talked about has been centered around programming. That seems to be the most obvious place. But we're also open to other ideas, so maybe networking, like especially if they're doing web programming and so on, maybe we could introduce some networking ideas and so on. So we're thinking about some different options. So now that you have an idea of what this project is, we'd like to open it up to ideas you might have. And Eloy now is going to lead the group discussion.
So any questions so far? So again, we're in the first 3 months of this project. It's a 2-year project. We'd like to, in a minute, we're going to post a few questions for you to discuss. Could you form yourself into groups of, I don't know, 3 or 4 people, and we can pass. We'd really like to get your kind of feedback on some of these questions. Some of the questions we'll be posting about some of the ideas that we covered.